Hello class, in this chapter we are going to be talking about networking with Windows Server 2008. It's going to talking about the basic of networking. A network is a group of two or more nodes, such as computers, printers, and other hardware devices linked together for sharing data. Networking is the practicing of designing, implementing, and managing a collection of computers and devices or a network. We have different types of networks, and you can also classify them according to the following characteristics: network scales, connection methodology, network architecture, network topology, and network protocol. When we talk about network scale, we are referring to how networks occupy geographic space. A network can range from a small home network to one that covers multiple locations and continents. If you refer to the table 3.1 in the book, you're going to find the common networks by scale along with a description and sample of each one. But the most common types of network that we manage today is the local area networks or LANs and the wide area networks or WANs. A LAN is no more than a private network that interconnects one or more subnets using high-speed network connection. On the other hand, a WAN is a group of networks spread across different geographic areas. WAN connection often use connections that have lower speeds than the LAN connection. Also, this kind of connections commonly run through an Internet Service Provider, or ISP for short, which allocates WAN connections for private network. Now let's talk about connection methodology, which defines the type of hardware technology used for connecting the network nodes. The common technologies used today are fiber optics, which is a medium that uses glass fiber for transmitting data via light, Ethernet, which uses physical cables to connect network devices, and wireless LAN, which uses radio frequency to transmit data between nodes. The other characteristic that falls into how we can categorize our networks is the network topology. The network topology categorizes network based on the physical and logical relationship among devices. A network topology defines the physical placements of the devices, the logical layout of the networks, and the protocol usage. Common network topologies include the star network and the mesh network. Many factors determine which topology to use, including the network speed, the hardware deployed, fault tolerance, and cost of implementation. Finally, in our list, we have the network protocol. Computers network require a communication protocol to allow network nodes to communicate with each other. This is what we call the network protocols. A protocol suite is a group of protocols that work together that provides network services. The most common suite used today is what we know the TCP/IP. TCP/IP actually is the basis for the Internet, the World Wide Web, and almost all of the networks. Let's talk now about the basic networks components. These components are the hardware devices that provide interconnections between computers and network resources such as printers. They include the following components: network interface cards, repeaters, hubs, bridges, switches, and routers. The roles of these devices are defined in the Open System Interconnection Model, or for short, the OSI model. This is a 7-layer reference model used to describe networks, the protocol they use, and the application running on them. The network interface cards, or NICs for short, are hardware cards installed in computers so the computers can connect to the physical network. NICs use a low-level network addressing system based on the Media Access Control Address, or MAC for short. MAC addresses are designed to be globally unique and allow clients to communicate on certain networks. Also, MAC addresses work on layer 2 of the OSI model. Then we have repeaters. A repeater is a hardware device that receives a signal and then resends it as a higher level of power so that it can travel longer distances between the start and end points of communications. On our following list, we have a hub, which is the most basic of the hardware devices that interconnect multiple nodes. Hubs have multiple ports to which nodes connect. When a packet arrives at one port, it is sent to all of the ports of the hub, except for the port of entry. The bandwidth available for usage by all of the devices connected to a hub is equal to its total port speed. Remember that bandwidth describes the amount of data that can travel from one network point to another within a specified time. Hubs work in the physical layer, layer 1, of the OSI model. Next in our list, we have the network bridges, which connect one or more network segments. Like a hub, a bridge uses MAC addresses for managing traffic. However, a bridge can learn from that traffic it processes, so it can associate a port with a specific MAC address to which it's connected. After the bridge associates a port and an address, it sends traffic for that address only to that port. This creates more efficient traffic on the network. Bridges work on the layer 2 of the OSI model. Next in our list, we have the switches. The switches work at layer 2 of the OSI model and forward frames between ports based on the MAC addresses. However, switches are more intelligent layer 2 devices because they forward only frames to the ports involved in sending and receiving the datagram. By design, switches cannot route traffic based on IP addresses, although some switches are designated as a layer 3 switches, meaning that they can route by IP address. They are basically a router and a switch combined into one device. These type of devices that span layers of the OSI model are referred to as multi-layer switches. For environment requiring connectivity to other subnets or the internet, these switches are connected to a router for forwarding traffic to other subnets or public networks. And finally, in our list of devices, we have the routers. Routers are responsible for forwarding packets between subnets or networks with different IP addressing schemes. Routers accomplish this task by viewing the header of the data packet and using routing tables to determine the best route for sending packets to their destination. Working on layer 3 of the OSI model, routers use dynamic routing protocol and preconfigured static routes to deliver packets using the best route possible between two subnets. Routers are always connected to at least two networks, such as a two LANs or a private network connected to the internet through an ISP. The connection of two or more networks with layer 3 devices is referred to as an internet work. Routers interconnect subnets of different types. You can build 3 distinct types of internet works: extranets, intranets, and the internet, a global network of networks. The extranet are 2 or more networks connected to each other within the same organization. However, this connection cannot be from LAN to LAN. Extranets require a connection to Metropolitan Area Network, or a WAN. Extranets do not require a connection to the internet. On the other hand, an intranet is a group of interconnected networks protected from external or public networks by hardware and software means. Intranets are typically used in private networks for organizations to provide resources such as web-based applications and printers.